Hi listeners, you are welcome to the continuation of our online physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAMB, WAEC, NECO and NAPTIP exams. For today's presentation, we shall be discussing the concept of temperature. This is in particular our video 22, which is specifically on the temperature and aspect of it. I am by name Bangbade AA. Before we proceed, we need to consider the learning outcome of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to define temperature. They should also be able to define thermometer. They should also be able to explain direct temperature measurements. And lastly, they should also be able to answer relevant UTM questions relating to direct temperature measurements. Now, to start with temperature. Temperature is the measure of degree of hotness or coldness of a body. I repeat, temperature is the measure of degree of hotness or coldness of a body. It is very important to take note that on a microscopic scale, temperature is directly related to the motion of the body's molecule. This is in accordance to kinetic theory of matter. Then, in fluid, in which molecules move about randomly, an increase in average speed or kinetic energy of the molecule is manifested as a rise in temperature or increase in temperature. In summary, increase in temperature can be measured in terms of increase in average speed or kinetic energy of any molecule. That is in a fluid. For a solid object, an increase in average speed or kinetic energy of the molecule is due to increase in temperature, i.e., increase in temperature will lead to increase in average speed or kinetic energy of the solid molecule. This causes increase in the vibration of the molecule. Now, having understood the definition of temperature, we need to now consider thermometer. A thermometer is a device with which the temperature of an object can be measured. I repeat, a thermometer is a device with which the temperature of a body can be measured. Now, having understood the definition of thermometer, we can now proceed to direct temperature measurements. Direct temperature measurements can be manifested in form of the following. 1. Expansion of a fixed volume of a gas, as in mercury in glass thermometer. So, a typical example of where direct temperature measurement is manifested in form of expansion of a fixed volume of a gas is in mercury in glass thermometer. Now, direct temperature measurement can also be manifested in form of change in pressure of a fixed volume of gas, as in constant volume gas thermometer. I repeat, change in pressure of a fixed volume of gas as found in constant volume thermometer. Another direct measurement of temperature is found in form of the change of electromotive force with temperature, as in thermocouple. I repeat, direct temperature measurement can be in form of change of electromotive force with temperature, as in thermocouple. Also, direct temperature measurement can come in form of change in electrical resistance of a wire, as found in resistance thermometer. I repeat, direct temperature measurement can also come in form of change in electrical resistance of a piece of wire as found in resistance thermometer. Now, having understood the various forms of direct temperature measurements, I think the next worthy of consideration is what we call thermometric liquid. Thermometric liquid are liquid used in making thermometer. I repeat, thermometric liquid are liquid used in making thermometer. Now, before you can now consider a liquid as a thermometric liquid, we need to consider some factors which are regarded as the property of a good thermometric liquid. I repeat, the essential property which a thermometric liquid must possess before it can be a good thermometric liquid include the following. 1. Such liquid should be a good conductor of electricity. I repeat, such a good thermometric liquid should be a good conductor of electricity. Also, the liquid must be opaque in the sense that it must be transparent, it must not be transparent. The liquid must be opaque means it must not be transparent. Also, a good thermometric liquid should have regular expansion over a wide range of temperature. I repeat, a good thermometric liquid should have a regular expansion over a wide range of temperature. Also, a good thermometric liquid must have high coefficient of expansion. I repeat, a good thermometric liquid must have high coefficient of expansion. In addition to this, a good thermometric liquid must have a low melting point and high melting point. I repeat, a good thermometric liquid must have a low melting point and high boiling point. Now, having understood the general properties of a good thermometric liquid, the next concept we shall be considering will now be to consider the specific examples of thermometric liquid, which are the mercury and alcohol. These are the two commonest thermometric liquid we have. Mercury and alcohol are two liquids which are generally used in thermometers. Now, considering mercury first. Mercury expands regularly and has a high boiling point, hence can be used up to fairly high temperature. However, it has a relatively high freezing point, which is minus 39 degrees Celsius. Hence, it cannot be used for low temperature work. I repeat, the limitation of mercury is that a high it has a relatively high freezing point, which is minus 39 degrees Celsius, and this makes it not to be suitable for measuring low temperature work. Having understood the property and limitation of mercury, the next is to proceed to alcohol. Alcohol expansion is not quite as regular as mercury is, but its freezing point is low. I repeat, alcohol expansion is not quite as regular as mercury is, but its freezing point is low, which is minus 115 degrees Celsius. Hence, it can be used to measure low temperature. It can be used at a low temperature, unlike mercury, which cannot be used to measure low temperature. However, alcohol cannot be used at high temperature because of its low boiling point, which is 78 degrees Celsius. I repeat, alcohol cannot be used at high temperature because of its low boiling point, which is 78 degrees Celsius. Don't forget, the summary of this is that mercury is suitable for measuring high temperature but cannot measure low temperature. Mercury has regular expansion, while alcohol on its own can be used to measure low temperature but cannot be used to measure high temperature. And alcohol does not have regular expansion as found in mercury. Now, having understood the thermometric property of mercury and alcohol as well as their limitation, the next body of consideration is to consider the summary of the temperature scale. A scale of temperature is a scale based on any thermometric substance. The fixed point normally used are the temperature of the melting ice, which represent the ice point, and that of the boiling water, which represent the steam point under standard temperature, under standard atmospheric pressure. I repeat, the scale of a temperature is the scale used on any thermometric substance, and the fixed point normally used are the temperature of the melting ice, which represent the ice point, and that of boiling water, which represent the steam point under standard atmospheric pressure. Now, the table summarizing the ice point and steam point for various scales of temperature we have is summarized in the table below, considering the steam point, the intermediate and the ice point representation. And with me here I have a table whose first column denotes the point, which can either be steam, intermediate and ice, followed by general symbol, and followed by each of the scale, first of which is centigrade, followed by absolute temperature in Fahrenheit. Now, the steam point under general symbol will be represented by x100. Under the steam point of centigrade is 100 degrees Celsius as shown in the table, while the steam point of absolute temperature is 373 Kelvin. That of Fahrenheit is 212 Fahrenheit. Now, for intermediate, we normally represent it generally by Tx. For centigrade, we represent the intermediate temperature by Tc. C is representing Celsius. For absolute Kelvin, we represent it by Tk, and for Fahrenheit, we represent it by Tf. F here represents Fahrenheit. Then lastly, for the ice point, the ice point is usually represented by x0 or 0. 100 degrees Celsius, the ice point represents 0 degrees Celsius. Under absolute Kelvin, the ice point is 273 Kelvin, while up under Fahrenheit, the ice point is 32 Fahrenheit, degree Fahrenheit. Now on to the sample questions from the UTME, and the first question we shall be considering comes from 2001, number 12. And the question goes thus: the thermometric substance of an absolute temperature of an absolute thermometer is dash. I repeat, the thermometric substance of an absolute thermometer is dash. Option A, you have alcohol. Option B is mercury. Option C is helium. Option D is platinum. So the correct answer here will be mercury. Mercury. Then the second question we shall be considering comes from 2002, number 21. And the question goes thus: water is a poor thermometric liquid. Water is a poor thermometric liquid because it A has a low pressure, B is opaque, C is a poor conductor, D it wet glass. So the best answer here is because water is a poor conductor of heat. Is a poor conductor. Then The next question we shall be considering comes from 2006, number 48. And the question goes thus: the thermometric property of a constant volume thermometer is dash. I repeat, the thermometric property of a constant volume thermometer is dash. You have option A to be change in pressure, option B is change in length, option D is differential expansion, while option C is differential expansion, while option D is change in volume. The correct answer here is A, that is change in pressure. Now, the next question we shall be considering comes from 2007, number 39. And the question goes thus: a clinical thermometer is different from other mercury in glass thermometer owing to dash. A, its long stem, B, the construction of its stem, C, its wide range of temperature, D, the grade of mercury. So the correct answer here is option B, which is the construction of its stem. Then the last question here comes from 2008, number 19, and the question goes thus: the thermometric property of a thermocouple is a change in dash. I repeat, the thermometric property of a thermocouple is the change in dash. So option A says equivalent resistance, option B says electromotive force, option C says color, while option D says pressure. So the correct answer here is option B, which is electromotive force. So the thermometric property of a thermocouple is a change in electromotive force. Now, here are some other questions for your own practice. The first question for your practice comes from 2009, number 18. And the question goes thus: the thermometer whose reading is indicated by a change in color of its thermometric property is the dash. I repeat, the thermometer whose reading is indicated by a change in color of its thermometric property is dash. You have option A, bimetallic strip thermometer, option B, thermocouple, option C, platinum resistant thermometer, while option D is optical pyrometer. Then the second question for your own practice comes from 2012, number 19. And the question goes thus: clinical thermometer are examples of dash. I repeat, clinical thermometer are examples of dash. A, pressure gas thermometer, B, resistance thermometer, C, alcohol in glass thermometer, D, mercury in glass thermometer. So the expected answer for question 1 and 2 here are option D. Question 1 is option D, question 2 is also option D. Our next video will be on the calculation on interconversion of temperatures with sample questions and solution from the UTME. There we shall be considering the UTME question dealing with conversion of scales of temperature from one form to another, e.g. Celsius to Fahrenheit, Fahrenheit to Celsius, temperature in Kelvin to Celsius, and so on. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you more interesting lectures on subjects relating to UTME and SSE. Thank you.